Up next with our rationals, we are going to multiply and divide them. And again, guys, fractions are rational expressions. So let's review what you would do with just basic fractions. So a little throwback. Number one in that warm up review says 3/4 times 1/2. How do you multiply fractions? And you would be surprised how many students just really don't remember how you would do it by hand. But we need to talk about how you do it by hand so we can do these polynomials. When you multiply fractions, you literally just go across the top and across the bottom. No tricks here. 3 times 1 is 3, 4 times 2 is 8. Done. Okay. Number 2 is a division problem. So what do you do there? So hopefully you remember in the past you had a math teacher that probably said, let's not divide our fractions. Instead, we change them to multiplying by the reciprocal. So some teachers call this keep, change, flip, or KCF. I'm going to use that acronym and that method for our notes here. You do keep, you change it to multiplication, and then you flip the second one to its reciprocal, and then you just multiply across the top and across the bottom, and we got 8/3. So we are going to do very similar things here with our polynomials. Our steps here, if you are dividing, you are going to use that KCF strategy of keeping the first expression, changing it to a multiplication problem, and then flipping your second expression. And then we're going to follow the steps that we did for simplifying. We're going to factor our numerator and denominator when possible, cancel out those common factors, and then combine or multiply what's left over. You're going to see this is very similar to our last lesson. So number one, you see we have two rational polynomial expressions that are being multiplied together. So I'm just going to start off top left, 3x minus 6, start with factoring it, seeing what I can do. So 3x minus 6, I can take out a GCF of a 3 and have x minus 2 left over. I'm going to go ahead and finish that expression. The denominator x plus 9, nothing I can do there. I am going to put parentheses around it so I'm not tempted to just cancel the x out and not the entire factor. It is multiplying. In the right expression, the numerator x squared plus 5x minus 36. Leading coefficient's 1, so I'm just going to think about the factors of a negative 36 that add up to 5. That's going to be 9 times negative 4. And throw that into my binomials. X plus 9, x minus 4, over. In my right denominator, x squared minus 6x plus 8. The factors of 8, that will add up to a negative 6. I'll need a negative 4 times a negative 2. Two negatives multiply together to make a positive. And put that in my binomials, x minus 4, x minus 2. All right. Once you are completely factored, then you can start chopping away anything from a numerator with a denominator. It can be in the same expression or it can be an opposite one. So like x minus 2's cancel, x minus 4's cancel, and the x plus 9's cancel. I gave us a really exciting one to begin with, and all that's left is 3. So that big, ugly problem is just 3. How fabulous is that? Let's look at number 2, the top left numerator, x squared minus 16x plus 64. Leading coefficient's 1, so I'm just going to think about the factors of 64. That would add up to a negative 16. That would be a negative 8 and negative 8, so x minus 8 times x minus 8. In the denominator, another leading coefficient of 1, so just the factors of 40, that would add up to a negative 13. I could do negative 5 and negative 8. So those factors would look like x minus 5, x minus 8. They are multiplying with this other expression. The top, the numerator in the right expression, 6x minus 30, you can take a GCF of a 6 out, and that would leave us with x minus 5. And the denominator, GCF, could be 3, and we have x plus 5. So you got to make sure you factor correctly, and let's see what we can do here. Now you can only cancel one set. So I know we have 3 x minus 8s, but we can only cancel a set because we're dividing. So same thing divided by same thing makes 1. The x minus 5 cancels. And then the 6 and the 3 can reduce. We can divide that and make that a 2. So in the numerator, we have a 2. We have one of those x minus 8s. And in the denominator, there's an x plus 5. Final answer. Again, I like to use parentheses around my factors, so I'm not tempted to go and cross out the pieces of my factors like the x's. Those are entire factors, entire families. Don't go chopping things away. Last example is a division problem. So I am going to keep this first one the way it is. We are going to change it to multiplication, and then I'm going to flip this one, the last one. So let's start factoring. The left numerator, I can remove GCF of a 5. So I'll have x plus 9. Denominator, factors of 27 that add up to 12, 9 and 3. So x plus 9 times x plus 3. We're going to change it to multiplication. So we got to flip that second expression. So now the x squared minus 9 is in my numerator. X squared minus 9. Actually, let me write that just for the sake of our notes here. And then I'll just copy this down. So we flipped that second expression. So now let's show factoring x squared minus 9. Do you recognize it? It's a difference of perfect squares, x plus 3, x minus 3. And our new denominator, the x squared minus 3x, the best you can do is a GCF of an x. And we are completely factored, ready to cancel common factors, x plus 9s, x plus 3s, x minus 3s. It looks like all we have left is the 5 in the numerator and x in the denominator. Big division problem, and all that's left is 5 over x. I really love when things cancel. Don't expect like everything to cancel. Sometimes it might just be one pair of factors. So just, it's okay. Double check your factoring. And that's multiplying and dividing those rational expressions. The biggest thing is watch out for a division problem. Delta Math obviously has your multiplication and division mixed. So watch out if it's division that you know that you're going to change it and flip it. You'll probably notice because things won't be canceling like you would expect. You'd have a lot of the same things in the numerator, a lot of the same things in the denominator. But watch out if you're dividing, change it to a multiplication problem, cancel like factors. Hope you're ready to factor some more. And I'll see you in class. Let me know if you have questions.